Good morning, everybody. Today is Tuesday, November 17th, and today we're going to talk some more about Punnett squares. Yay! Okay. We're basically going to just be practicing Punnett squares this whole entire class period. All right. So, for those of y'all watching at home, you can find the worksheet that I'm using for these Punnett squares right here on the Schoology page. You can, if you have a printer, you can print it out and fill it out, or if you don't have a printer, that's okay. Just write it on a piece of paper. That's what we're doing here in class. We're just writing them on our piece of paper, okay? Either way is fine with me as long as you're practicing these Punnett squares, okay? Um, so I'm going to share my screen, my camera, okay? So you can see how I complete these Punnett squares, okay? So this is the worksheet printed out that's on Schoology, okay? You can either print it out or you can just follow along with us, but this is where I'm getting the examples from um, to do these, okay? I'm going to go over a few of them here in class with you right now, and then the rest of them you're going to be in charge of doing on your own, okay? So you can find the rest of the problems on your Schoology page to complete on your own practice, okay? So first one I'm going to do, and whenever you are doing Punnett squares, two things. Remember, we always start with the parents, okay? And I will always give you the parents' information. You'll never have to like guess that. Now, I might not give you the exact genotype letters, but you should know how to figure out genotypes by now because we practiced that all last week, okay? All right, so the first plant, and the second thing is that filling out the Punnett square part is only part of doing the Punnett square, okay? Make sure you're doing the percentages as well. Let's do number one here, okay? Number one says a green pea plant that is heterozygous, big G, little g, is crossed with a yellow pea plant, little g, which is the recessive color, okay? So we have green pea parent, and we have a yellow pea parent for our two parents, okay? Those are our two genotypes. So the first step is to draw our Punnett square. And we always start with the parents. Where do the parents go? They go on the outside of the Punnett square, okay? So the first parent, big G, little g, and remember we don't write those G's next to each other. Remember the law of segregation said that those allele letters separate, those chromosomes separated, okay, during anaphase. They do not go next to each other. So you put one G above the first column and another G above the second column. They separate away from each other, okay? That's the first parent. Second parent is two little g's, and it goes on the side over here. And again, don't write them next to each other. We put one little g next to the first row and another little g next to the second row, okay? So we've got our parents. Now we need to figure out what kinds of traits the offspring could inherit from these parents. So we're going to cross them. And remember, you're looking at what two G's are intersecting in each box, okay? So this first gamete box right here, what's above it and what's beside it? Okay, so we have a big G from above it and a little g beside it. That's the first gamete. Second gamete box, what's above it? A little g is above it, and a big G is beside it. Third gamete box, big G is above it, little g is beside it. And the fourth gamete box, little g is above it, little g is beside it. Okay, so those are the possible genotypes that our offspring could inherit from their parents' gametes, from the sperm and egg. Okay, so this would be like the pollen, the male sperm, and this would be like the female egg, or other way around. We don't know which one was male, which one was female. We just know the genotypes, okay? So Let's do our probability percentages of how much percent chance the offspring will have of getting the different genotypes, okay? So next to the paper, or next to the Punnett square on your paper, right, genotypes, okay? And remember, there are 3 kinds of genotypes that are possible. We could have homozygous dominant, HOMDOM. We could have heterozygous, or we could have homozygous recessive, HOMREC, okay? What kind of G's would we be looking for homozygous dominant? Remember, homo means same and dominant means big. So we're looking for 2 big G's. Do we have any offspring right here that inherited 2 big G's from their parents? Nope. So that would be a 0 out of 4 probability, which is what percent? 0% chance. Their offspring are not going to be homozygous dominant. No way. 0%. Okay. Heterozygous. Remember, hetero means 2 different size letters. Okay. So we have a big G and a little g. How many of the offspring boxes got a big G and a little g? 1, 2. 2 out of 4. Which is what percent chance? 50% chance. Okay. Next one is homozygous recessive. Okay. So remember, homozygous means same, recessive means little. So 2 little g's. Do we have any offspring boxes with 2 little g's? Yes, we do. We have this one right here and this one right here. 2 out of 4, which is what percent chance? 50% chance. Okay. So it's a 50-50 shot whether their kids are going to be heterozygous or homozygous recessive. Okay. Now we need to figure out the phenotypes. And remember, phenotypes means what they can physically look like when you physically look at the plant. Okay. So when you look at these pea plant babies, are you going to look at G's on the peas? Is there going to be a little G on the pea? No. What are you going to see when you look at the pea? You're going to see what color it is. Okay. And our 2 colors here are green and yellow. Green and yellow. Okay. Now, how do we know which one's the dominant color here? Well, if it was dominant, what kind of G would we be looking for? A big G or a little g? We'd be looking for a big G. Which of the parents had a big G? This one. What color was that one? Green. So we know that the green is the big dominant color, okay? So we're looking for how many of the offspring boxes are going to inherit a big G and be green color. How many of them have a big G? Here's a big G. Here's a big G. 2 out of 4. What percent chance is that? 50% chance. Okay. So we know if green is the dominant color, that means yellow is recessive. What kind of G's would we be looking for recessive? Little g's. Okay. Now, all of our boxes have a little g. But remember, for recessive traits, how many little letters do you have to have? They have to both be recessive, both little letters, okay? So even though these 2 have a little g, they are not going to be yellow recessive color because they have a big G, and the big G is going to win. It's going to be green, okay? So the little g is going to hide. You won't see yellow color in these ones. You will only see yellow color if there's no big letters around. So 1, 2 of the offspring boxes are yellow color, which is, again, 50% chance. So 50% chance they will have green peas, 50% chance they will have yellow peas. Okay? Let's do another one. So I'm going to erase some of this stuff. And we'll go on to number 2 on our worksheet. Number 2 says a tall plant with 2 big T's is crossed with another tall plant, but this time it's heterozygous, big T, little t, but it's still tall. Okay. All right. So remember, first thing we do, draw our Punnett square. What do we write first? We write the parents, because you can have babies if you don't have parents, right? You got to have parents first. Where do the parents go? On the inside or the outside? On the outside. Okay. So the first parent, big T, goes on the top. And the second parent, big T, little t, goes on the side. Now we're going to cross them. First box, what goes here? Big T from the top, big T from the side. Second box, big T from the top, big T from the side. Third gamete, big T from the top, little t from the side. And fourth gamete, big T from the top, little t from the side. Okay? All right, now let's do our genotype percent chances, okay? Homozygous dominant, remember, is 2 big letters. So we're looking for how many gamete boxes have 2 big T's. This one and this one. So 2 out of 4 equals what percent? 50%. Okay. Heterozygous, you're looking for 2 different size T's. How many have different size T's? Big T, little t, right here. 2 out of 4 equals 50%. Okay. Homozygous recessive, we're looking for what kind? 2 little t's. Do we have any gamete boxes with only little t's? Nope. 0% chance. Okay. All right, now our phenotypes for these plants. We know that one of the phenotypes is tall, right? Tall. That means, what do you think the other one is? Short. Which one is the dominant, tall or short? Well, the parents are both tall, and the parents both have a big T. So that means tall is dominant, okay? So what kind of T are we looking for tall plants here? A big T. How many of our gamete boxes have a big T in them? All 4. 1, 2, 3, 4. All 4 of them, okay? So what percent chance will their babies have of being tall plants? 100%. 4 out of 4 is 100%. That means none of them are going to be short. Even though these two have a little t, are they going to be short? No, why not? Because they got a big T, okay? So big T is going to win. So 0 out of 4 equals 0% chance of having short offspring, okay? All right, let's do another one. And this time, I'm going to set it up, and I want you to pause the video and do it on your own, okay? So here we go. Number 3, we have another tall plant that is heterozygous, tall plant. And this time we're going to cross it with a short plant. And if it's short, we know that's recessive. So they're going to have 2 little t's, okay? All right, so pause the video and do this on your own. All right, so hopefully you're done by now. Okay, I'm going to quickly fill out the Punnett square, and hopefully you got the same answer. Okay, all right, genotype percents. How many are homozygous dominant with 2 big T's? None. 0 out of 4 is 0%. Heterozygous, how many have a big T and a little t? 1, 2 out of 4, which is 50% chance. How many are homozygous recessive with little t's? 1, 2. 2 out of 4, 50% chance. Okay. Phenotypes. What are our 2 phenotypes that we would see when we look at these plants? Well, let's look at the parents. tall, short, tall, short. Okay. Which one's dominant? This parent has a big T and it's tall, so that's the dominant one. So what kind of T's are we looking for tall plants? Big T's. So 1, 2. 2 out of 4, 50% chance of being tall babies. Short is recessive. What kind of thing are we looking for here? 2 little t's. Okay. So that would be also 2 out of 4, which is 50% chance. Okay. All right. I am going to flip over to the back side of that worksheet and give you a more complicated one. Okay. So now we're looking at the back side. All right. And we're going to look at number 2 on the back. Okay. So backside now, number 2, because I want to go ahead and show you one that's more complicated like this, okay? So number 2 on the back says 2 heterozygous white rabbits are crossed and brown fur is recessive, okay? So we have 2 heterozygous white rabbits. It does not give you the genotype letters. It's tricky. It does give you the genotypes though. They're heterozygous, okay? And we know how to write a heterozygous genotype. Heterozygous means 2 different size letters, right? And if white is the dominant fur color, what kind of letter of the alphabet should we use? W's, okay? So we're going to have a big W and a little w, white rabbit, crossed with another big W, little w, white rabbit. And brown fur is recessive, it says, okay? Let's go ahead, pause the video, and fill out your Punnett square for these 2 white rabbits, okay? All right, I'm going to quickly fill it out because this one's a little bit more complicated. This is kind of like the examples we did yesterday at the end of class, okay? So first parent, remember, goes on top, big W, little w. Second parent goes on the side, big W, little w. First box, 2 big W's. Second box, little w from the top, big W from the side. Now remember, you write the big one first because that way we can remind ourselves that that one's the one that's going to show. That's the big brother likes to win, okay? Third gamete, big W from the top, little w from the side, and fourth gamete, 2 little w's, okay? Did y'all get that answer? You good? I know, this one's a little bit more complicated, okay? All right, so our genotypes over here. First kind of genotype they could have gotten is homozygous dominant. What kind of W's are we looking for homozygous dominant? 2 big W's. How many gamete boxes do we see with 2 big W's? 1. This one right here. 1 out of 4. What percent chance is 1 out of 4? 25% chance. Okay. Heterozygous, what kind of W's are we looking for? A big W and a little w. How many boxes do we see with a big W and a little w? These 2. 2 out of 4, which is 50% chance. Okay. Homozygous recessive. What kind of W's? 2 little w's. That's this one. Little w, which is only 1 box out of 4, which is what percent chance? 25% chance of being homozygous recessive. Okay. Now, for our phenotypes, we had 2 color furs that we could see for our phenotypes. Either white fur or brown fur. Which one did we say was the dominant color? White fur. So what kind of W's are we looking for white fur? Big W's. We have a big W here. We have a big W here. And a big W here. So how many gamete boxes had a big W? 3 out of 4, which is what percent chance? 75% chance of looking like their parents and having white fur, okay? Brown, we said, was recessive. So what kind of W's are we looking for brown fur? Only little W's. Remember, you can't have a big W if it's recessive. So even though these have a little W, they're going to be recessive white fur, not brown. This is the only one that's brown fur. So 25% chance of not looking like their parents and having brown fur. Okay? All right. So you guys practice more on your own. Practice, practice, practice. You will have a quiz on this on Thursday, so you will need to know how to do these on your own, okay? If you have any questions, let me know. I'll be here for you, okay? Bye.